Here's the thing about the good times in life. We don't always realize we're in them. It's a beautiful time for basketball.
And now we'd like to welcome Anastasios. Get up. He's one of us. He's a student, was a student in the department, and he's been doing some great work as far as data management. And he's going to show us how to predict the shot success in the NBA. So very interesting.
Good afternoon, everyone, and welcome to my presentation. First of all, I would like to thank the organizational committee of AUEB Sports Analytics Group for this invitation, and especially Professor Dimitris Karlis for his insightful feedback during the implementation of this paper. My name is Anastasios Pliatsikas, and over the course of the next 20 minutes, I'm going to talk to you about predicting shot success in NBA. Why is this important? If you're anything like me or Professor Egidi, you may be able to stop losing at betting. Here is some information regarding my background and my job as a data scientist at eWorks, but let's just skip to the main part. Okay, the main limitations faced in previous studies that attempt to predict shot success were related to the data used in their analysis. In this regard, we decided to create a large dataset from an entire NBA season and with many features extracted from various data sources, thus enabling the multi-purpose usage of our data. Our main goal is to identify the best classification method for predicting shot success. During this quest, we also gained insights regarding the factors affecting shooting effectiveness. Our research was initially conducted for all types of field goals, and then we focused on 2-point and 3-point shots. Here's a quick overview of what we'll be covering today. We will start with a brief introduction about the NBA, and then continue with the data preparation process. In Chapter 3, we will present some visualizations from the NBA's 2014-15 season. Then, we're going to describe our methodology, and in Chapter 5, we will apply the same methodology for 2-point and 3-point shots separately. Finally, we're going to close by stating the major findings and with some concluding remarks. So, basketball was invented in 1891 by James Naismith, who set 13 simple rules on how the game should be played, which for the most part are valid till today. The game grew immensely popular during the 20th century, with the NBA being founded in 1946. The adoption of three-point line back in 1979 completely changed how the game is played. Since 2013, NBA has been using a 6-camera system to collect tracking data. StatsPerform was the main video tracking provider up until 2017, before switching to Second Spectrum. So, where it's today, where NBA is currently the third wealthiest sports league with an annual revenue of about $10 billion. Per Michael Jordan, NBA is the strongest professional sports league in the world. Let's now proceed to the second chapter concerning data preparation. First of all, to predict shot success, I guess we need data related to shots. In this regard, we decided to use shot tracking data collected with Sport UV tracking technology. However, as of 2016, NBA has restricted public access, which is why we acquired data from the NBASavant.com. Assuming that shot success can be affected by many factors, we also included play-by-play data from the Hooper package, along with a variety of features such as total and per-game stats, player bios, and team rankings. The latter three were acquired from multiple data sources like Basketball Reference, B-Ball Index, and NBA.com. For easier understanding, we divided the data processing into 6 major sections. First, we begin with the shot location and shot type segmentation. Using the X and Y provided coordinates, we computed the shooting distance and the angle of the shooter position, which enabled us to divide the court into multiple shooting zones. In our analysis, we have split the court into 5 main shooting zones, as illustrated in the figure on the left. We also distinguish shot location between left, center, or right side of the court. Furthermore, we divided shots into multiple shooting types, like jump shots, layups, and dunks. For quantifying the defensive pressure, we used the closest defender distance. Our analysis revealed that the most effective grouping was based on 2-foot distance ranges, which equals to 0.6 meters. We also quantified the mental pressure of a player when attempting a shot based on whether his team is leading or trailing and to what extent. Let's now continue with the time-related information in our data. By grouping the time left on the shot clock into 5-second intervals, we characterize the possession type based on when the shot was attempted. We also use the game clock as indication of the player's fatigue and to see whether a shot was attempted in clutch time, which refers to the final 5 minutes of a game where it's within 5 points or less. Based on how long a player touched the ball before shooting, we were able to distinguish, for example, the ball hoggers in a separate category, which we named after James Harden, for obvious reasons. We also reviewed whether a player is hot by checking the result of his last 5 shots. Using this information, we computed the number of consecutive shots made and the corresponding percentage. We also included information relative to each player's height, weight, and speed. This allowed us to know whether the shooter was quicker, heavier, or taller than his closest defender, and by what amount. Using this information along with the shooting distance, we measured the size of a mismatch. From our exploratory data analysis, we observed that the dunks were by far the most effective shooting type, with more than 90% of them being made. As a result, we decided to exclude the dunks from our analysis to avoid any potential problems like overfitting. Let's now continue with the third chapter of our presentation. In this plot, we showcase the field goal percentage per shooting distance. From the first 2 bars, we observe that the shots attempted close to the basket are affected the most when contested, with defenses being able to prevent 20% of them. This explains the tendency of many teams to protect the rim at all costs. It is also clear that as shooting distance increases, shot probability decreases. With that in mind, we reviewed how the shooting distance affected each player's shooting effectiveness. What's notable is that DeAndre Jordan led the league in field goal percentage. The reason for this lies in his shot chart, where we see that almost all of his shot attempts were under the basket, with an average distance equal to the size of a pizza. We also reviewed how the shooting efficiency is affected by the time left on the shot clock. Regarding the 2-point shots, we observe that players tend to shoot a lot better when more time is left on the shot clock. These shots tend to be easier as they probably occur during a fast break or after an offensive rebound. On the other hand, we see that 3-point shots were not affected by the time left on the shot clock, with the shooting percentages being relatively stable, with the worst ones occurring near the end of the shot clock, which is usually the result of a good defense. Furthermore, we differentiate 3-point shots based on whether they are catch and shoot, meaning that a player shoots without dribbling, or a pull-up. Regarding the catch and shoot specialists, we see that among the best shooters were the Splash brothers, named Steph Curry and Klay Thompson, who had among the highest field goal percentages despite shooting at a high volume. As for the pull-up threes, we see that the best shooter both in frequency and accuracy was by far Steph Curry, followed by James Harden. In general, catch and shoot is considered a much easier shot than the pull-up. Nevertheless, we see that Steph Curry knocked them down at nearly the same rate. No wonder he became the NBA's all-time leader in three-pointers. We also highlighted the best and worst shooters per shooting zone. What's striking is that the point guard, Chris Paul, was the most effective scorer from the paint. As for the least effective shooters, we see that Russell Westbrook justified the Westbrook nickname by shooting a league-worst 30% from the mid-range. Okay, this slide is not shown. Anyway, I'm going to describe it. A famous quote says that offense wins games, but defense wins championships. To measure the defensive ability, we computed the opponent's points per possession and the opponent's field goal percentage. We also calculated for each defender the average distance of a player when guarding a shot and the average shooting distance to identify whether a player defends close or away from the basket. Finally, we kept track of how many shots were attempted against his defender and how many of them were contested. To identify the best defenders in the league, we compare the opponent's points per possession, which is not shown, with the rest of the metrics. To avoid having small sample sizes influencing our results, we only included players who have guarded at least 200 shots. So, after comparing our results, we noticed that among the best defenders in the league were players like Tony Allen, Anthony Davis, and Draymond Green. we also observed that the length and agility of some players allowed them to quickly recover and contest shots from a greater distance. In the right plot, we see that from the players that could do this, the best ones were Tony Allen, Anthony Davis, and Serge Ibaka, which especially for the latter two, who are power forwards starting at 2.10 meters tall, is pretty impressive. Rim protection is considered the cornerstone of a team's defense. That's because when perimeter defense fails, the rim protector can be there to back it up. So by focusing on the players guarding shots in the restricted area, we observed that the best rim protectors in the league for that season were DeAndre Jordan and Pau Gasol. What's interesting is that in contrast with the rest of the players in this list, Pau Gasol was mostly known for his offensive ability and was not perceived as a good rim protector. As a tribute for becoming the NBA's all-time leading scorer, we also created LeBron James' shot chart and compared his field goal percentage per shooting zone to the league average. The redder the color, the better LeBron shot compared to the rest of the league. So we see that the most red color is under the basket, thus confirming his dominance in the restricted area. He is also very good at shooting the mid-range from the center of the court, the corner three from the left, and the above the break three from the right. Enough with the plots, let's continue with describing our methodology. Since we want to predict whether a shot is made or missed, we face a binary classification problem. Prior to our analysis, we randomly split our data into three subsets. In particular, we used 70% of them as a training set to fit its model, and 15% as the test set for hyperparameter tuning and model evaluation. The rest 15% was a validation set, which we used to obtain an unbiased evaluation of the best models fit. To assess the performance of our models, we used the confusion matrix to compute several metrics. Considering that the NBA is a make or miss league in the sense that teams win or lose games by making or missing shots, we deemed that the cost of false positives and false negatives were essentially the same in our analysis. As a result, we used the F1 score as our main evaluation metric. So we developed 6 different classification models. Note that the implementation of naive-based and tree-based models did not demand scaling their features. However, for the less classification models, namely KNN, logistic regression, and linear probability, we scaled their features as they were sensitive to the variance in the data. Let's now continue with how we identified the best classification method. As already discussed, we have randomly split our data into 3 subsets. This procedure was repeated multiple times to decrease the uncertainty of an unfortunate split. By computing the mean value of the performance metrics, we evaluated our models. After comparing these metrics and checking the stability of our models, the random forest seemed to perform better. We then applied this method in the validation set to see how it performs on unseen data. So overall, the best method was random forest. Let's now head to chapter 5. In this plot, we see that the number of 3-point shot attempts has increased every year for the past decade. The reason for this lies in its efficiency, as teams have realized that by shooting more threes they could score more points, and in the spacing created into the floor. Based on the foregoing, we decided to apply the same methodology we previously discussed for predicting shot success of 2-point and 3-point shots separately. After comparing our results, we noticed that the best method to predict shot success of 2-point shots was logistic regression, and for 3-point shots, it was random forest. Time for the final part of our presentation, because all good things must come to an end. The accuracy benchmark, along with results from past literature, were used as a point of reference for comparing our results. So, not only we were able to increase the predictive accuracy, but also achieve very high F1 scores, which was our main evaluation metric. Our analysis revealed that there was not a clear-cut factor influencing a shot success, but there were some factors with a greater influence. In this plot, the most important indicators are the ones at the top. So we see that the shot success is highly influenced by spatial-temporal aspects, mainly the shooting distance, and by each player's shooting abilities. In general, to predict shot success, we need features collected during a game, field goal percentage stats from an entire NBA season, and metrics indicating each shooter's and defender's abilities. When we focus on the 3-pointers, we observe that the success was mainly affected by each player's field goal percentage per shooting zone. We also observed a significant shift in importance between the rest indicators, which were related to the score difference, the time left on the shot clock, and metrics indicating defensive abilities. What's interesting is that the least influential variable concerned the time a player held the ball before shooting. A real-life example is Klay Thompson, a three-point specialist, who was able to score 60 points while holding the ball for just 90 seconds. As for the two-point shots, we observed that the success was mainly affected by the shooting zone, and in particular, the shooting distance. Other factors highly influencing the success were the defensive pressure, the possession type, each player's shooting ability, and the score difference. To a lesser extent, the success of two-pointers was affected by each player's offensive and defensive role, the shooting angle, and the number of dribbles made before shooting. Finally, the lowest impact on the success of two-point shots had factors like the speed difference between the shooter and his closest defender, the hot hand, and other seasonal stats like the usage and true shooting percentage. So we see that the hot hand had indeed some influence on the shot success, but not as much as many players and basketball fans believe it to be. Okay, our study could assist coaches and general managers in better understanding the players' abilities and shot selection at every moment of the game. As a result, it could help with in-game strategy by creating efficient game plans and lineups, and with roster construction by acquiring players complementary to a team's needs. It could also help with adjusting players' training regimes to improve their ability to make or defend shots. Finally, in our analysis, we have excluded the player identities, and thus it could help with obtaining a generic player's shooting performance and compare it to that of a certain player. So, where can we actually take this? From a data standpoint, we could analyze multiple NBA seasons or collect more tracking data to determine, for example, whether the shooter was guarded by multiple defenders, or whether the defender was in front, behind, left, or right from the shooter, or even the defensive switches during a possession. It could also be interesting to know whether the defender raised his arm when contesting a shot, as this would increase the shot's difficulty, or if the defender was in foul trouble when guarding a shot. We could also review the player's fatigue during and between games. From a more technical standpoint, we could analyze multiple NBA seasons, experiment with more classifiers, or add more variations to our analysis. Here are some references. Thank you very much for your attention. If you have any questions, I will be happy to answer them.
For the logistic regression, how did you do variable selection? Do you use some regularization approaches like Lasso, or what did you do?
Okay, first I start with Lasso regression to do a screening regarding the variables, and then continue with some variable selection methods, mainly using the IQ criterion, stepwise.
What was Pedro?
I have a more game theoretic question. When you showed about LeBron, his shooting abilities throughout the terrain,
Yes.
I had a similar idea myself some time ago. I'm sure that Lakers know this. So they should have told or advised LeBron where to shoot. But on the same time, the other teams know this and they know how to guard LeBron. So if we see this from a game theoretic point of view, what happens there? I mean, you see, you understand what I'm saying?
Why they can't guard him in these areas? Regarding the three-point shots, I'm gonna answer by a more basketball standpoint, because if you see LeBron shooting three-pointers, he always takes a step back and go to the left. So this is very difficult to guard. As for his dominance in the restricted area, he's LeBron James.
Good luck with guarding LeBron. I've tried. Anybody else? Anybody?
I'm not into basketball either. I would like to ask about accuracy, and if you take into account the trajectory and the speed of the ball, and if you have access to that data, and if not,
Okay.
if you can calculate them alone.
That's what I want to collect more tracking data in the future work. I didn't have access to that, and would really like to use it. If you also search in the web, you see that Steph Curry trains by tracking his shot accuracy and see where the ball hits, and he always tries to hit the ball in the front of the rim. So so he used your idea to train. This is the reason he became so good at shooting.
Thank you.
There's no chance data available, but the teams have it in the private. If I can add something. Okay, as much as I like basketball, another one coming up. Any other questions? No? Thank you. Thank you very much.